video I wanted to talk about the Common Core exam in geometry, the Regents one, from June 2015. I wanted to break down the first 5 multiple choice questions into smaller pieces, show you what it looked like, show you the answer, and then where the materials would have hit it right on. The first one is definitely the right cluster. This is geometric measure, and it deals with the revolving around an axis. You'll see these materials hit it right on. And number 2, I actually think this cluster here about congruence isn't quite right. This is about congruence here, but really I think it's more about developing the ideas of isometry. So I'm going to talk about where I think you would want to be teaching to get that one right. The next one is in the area of calculations and coordinate grids, which is exactly correct. It is in the context of a circle, but really it's a question, can you use the distance formula? In number 4, we are now talking about the basic motion of translations, rotations, reflections, and recognizing them. This is the right place to look for that. It's in the properties that we're going to find the good recognition of those. And then the 5th and final one is just a classic trig problem. It's perfectly clustered. Everything's ready to go. We're now going to look at each question and where they're found in the materials and how the materials will help your students succeed on this exam.
All right, let's look at question 1. It says, which object is formed when the right triangle RST shown below is rotated around its leg? Now, this is definitely the right cluster, GMD B. This is the one that speaks specifically to the idea of revolving around an axis. Now, this one happens to be a classic, right? And the way I always draw these is I kind of draw in the reflected image, and it helps me to think about what's going to happen. Now, as I rotate, rotate this shape around that axis, it creates a solid. And it's asking me about what solid is being formed. Will it be a pyramid with a square base? Now, first of all, when you revolve, you will actually always create circular items, cylinders and spheres and cones and those kinds of things. So that's out of the game. A right triangle is a 2D object. That's out of the game. We make a solid. When you revolve around a leg, you create solids, a 3D object. This is out. It's definitely our cone. Now I want to just quickly take you through some of the materials that are provided in Geometry Common Core here that would help with this question. So here are some of the notes that are obviously speaking to that idea of revolving, using the idea of a revolving door to create the 3-dimensional solid. Other examples of different images that are revolving around an axis. So there's notes that are provided that hit this. Here is one of the worksheets. This, of course, the very first question is the question on the test. Interesting enough, cylinders and spheres and toruses and cylinders with missing cylinders and so on. You can see that the materials definitely hit this particular question and objective. Here's the idea of a pottery wheel and spinning it, and what would be the cross section of that, or if these were the cross sections, what kind of pot would you get? And then finally, here's a full-on activity using the internet where the students define a certain region, and then the software spins that item, and so they get all kinds of dimensional. So we're getting into much more complex things in that first question, but you can see that these materials hit this question right on. All right, let's look at question 2. The vertices of triangle JKL have the coordinates provided. Under which transformation is the image J prime, K prime, L prime not congruent? Now, well, this is a question about congruence, so they've clustered it under the B cluster, which is understand congruence in terms of rigid motion. This is really not a question about congruence. This is a question about isometries. In other words, the earlier objectives, GCOA2 and GCOA4, where we define those properties, is really at the heart of this question. And so this is not an issue of congruence as much as it is about isometries, translation, isometry, rotation, isometry, reflection, isometry, dilation, not isometric. Done deal. Immediately done without any really discussion of congruence. So to answer this correctly, it's about building the earlier concepts of isometry and definitions of transformations. Let's look at where we'll find that in the materials. As I mentioned, I'm actually going to show you some of the notes and items from the earlier objectives, GCOA 2 and A4. While this standard is denoted for congruence.b being its standard, these earlier ones are the ones that actually will make that question simple, because the focus is it's about congruence, but the focus is on the idea of isometries. In GCO2, the notes clearly lay out that we've got rotations and translations and items that are what are we called isometric, and then we look at a dilation or a stretch as ways that are not isometric. So that concept is developed earlier. Here's one of the worksheets where they start looking at shapes that are isometric and not isometric. They get that idea very quickly. Here's one where they take a triangle and use a coordinate rule, get some points and plot it, and then determine if it's isometric. The second area where a student will succeed on this question is based off of GCOA4, which is where we define the isometric transformations. Notice, a reflection over a line is an isometric transformation, and then it goes through and talks about properties, and then it talks about the next isometric transformation. Another place you'll find support for this question is in the assessment bank. Here are a few questions. The shape property is not guaranteed in isometric transformation. Guess which is not guaranteed? Isometric transformations and rigid motions. Again, we're defining what it means to be isometric. What properties does it hold? Which of the following is not isometric? There is the question basically that's being asked here. It's being asked about congruence, but it truly is a question of isometries, and do you understand rigid motion? Let's look at question 3. The center of a circle Q has coordinates 3 and -2. If the circle passes through R, 7 and 1, what is the length of the diameter? Now this is a circle question, no doubt about it, but it's really a distance formula question. It's giving you a center, a radius point, and then when you find that distance using your coordinates, using the Pythagorean theorem or the distance formula, you double it. So really we're looking for where did we have problems and questions that are about distance, distance formula, and then the idea of using it in context of a circle. Let's look at where we find that in the materials. This question is just really a classic question about the distance formula, but kind of put into a context in terms of finding diameter and things like that. And so again, let me show you a few places. This one is right on the nose, GPE B standard. We talk about the distance formula. We relate it to the Pythagorean theorem in these materials. We provide them specific examples. We look at basically the exact question. What's the radius of the circle that has a center here and a point on the circle? Now, the one that just got asked was about the diameter, so obviously doubling that, but we have ones like that as well. Here's off of a worksheet where they're just connecting again the Pythagorean theorem to the distance formula and then just doing some basic distance. And then again on worksheets, here's another one where we give a center and a point on, and we ask for the equation of the circle. That's a nice connection to another standard there. A little bit different, but here we are, center, radius, diameters, and so on. So this question definitely gets dealt with right here in the materials. All right, let's look at question 4. In the diagram below, congruent figures 1, 2, and 3. So we're in a congruence world here. Are drawn. So this is them. And then it asks, which sequence of transformations maps figure 1 onto 2 and 2 onto 3? Now this is this is in the right area, this is the right cluster, and we definitely want students to recognize what rotations and translations and reflections look like. Well, they can do this by eye in this case because it's so simple. The materials focus on teaching them to look at things like, do you see how all points here move in a translated parallel direction? We would notice they're all the same distance. We would notice the orientations are the same. Therefore, it has the characteristics of a translation. Here we would notice from here to here, the distances differ. E to E, E prime to E double prime, A prime to A double prime are different. And they do not move in a parallel manner. And their orientations, A prime, B prime, C prime, A double prime, B double prime, are the same. This must be a rotation. So really, to me, this question, while it's a very simple one, I don't think many students are going to get this wrong. To me, this is about teaching them how to recognize the properties of these motions. There are definitely isometric, but there are properties related to their distance, the parallelism that's formed, the orientation of the shape, and those things. And those are found in GCO 4, property-based information. This one really just gets at the heart of recognizing transformations, the isometric ones. And listen, there is plenty in these materials for that. So obviously there's just the notes that talk about the characteristics of a reflection and how they work, and that they're isometric, that distances are different and orientation is reversed, and so on. Rotations, and it goes through all of those guys in great depth, which is important. Then there's worksheets that help them to recognize where are the translations and the reflections and the rotations. Questions that ask them about the properties. So why is this a rotation? What is it about it? Not that it just looks like a turn, but the distances are different, but the orientation is the same. That must be a rotation, that kind of thing. We talk about the coordinate rules, and we see them in a visual sense, what's taking place on these different types of rotations and reflections. We go through physically doing reflections. We go through doing rotations. We practice translation. So when they see a question like this, this is pure points, easy stuff for them to do. The fifth question in our group here is a classic. There's no real surprise here. This is just a standard trig question with a tree. Find its height. Everything's nice. Labeling is provided, nothing tricky in the wording, but it says, as shown in the diagram below, the angle of elevation from the point on the ground to the top of the tree is 34. If the point is 20 feet from the base, so we have to label that, what is the height of the tree to the nearest tenth of a foot? And so again, we label in here, our 20 feet is from the base to here, and then we label our unknown here. This would be a tangent question. The tangent of 34 is x over 20, and then we cross multiply, and we find that our solution is 13.5. A very easy, straightforward style of question, and definitely gets hit a lot in the materials. Let's look at that now. There's nothing really tricky here to show you. We cover a whole lot of information about basic trigonometry and the application problems. And so this is just a standard classic tree problem, height of tree, that kind of thing. But just to show you what the materials provide you here, we talk about angles of elevation and angles of depression. Talk about the common air that takes place there. We identify the words used in ladder problems and kite problems and guy wire problems and shadow problems and so on. We got a great problem dealing with the angles of elevation and depression. Whoa, there's a tree problem. Whoa, there's a kite and a tree problem. Well, guy wires, helicopters, heights of people, all the classic kinds of questions, ones that are not labeled and they have to go from word to label and so on. We're ready to handle a problem like this, no doubt about it.